Okay, everybody, good afternoon. Welcome back to another ngiot webinar. This webinar is a part of a series that we organize in the context of ngiot Work Package 2, which is coordinated by the Istituto Italiano Privacy, and my colleagues from the Istituto Italiano Privacy, Audino and Francesco Capparelli are here, and I will give them the floor immediately afterwards. I'm Pasquale Annicchino from Archimede Solutions, and I also work in the context of the ngiot project, which is a CSA which supports and work with different research projects in the context of IoT. Today, we are very much honored to have two researchers from SINTEF with us, Nicolas Ferry and Hui Song, and will speak to us about a specific project on which they are working, which is the ENACT project. And the title of that we gave to the webinar is DevOps for Trustworthy IoT Systems. So we look forward to hearing from them on the work they are carrying on and doing. I just wanted to remember to all of you that this webinar is registered and will be later updated on the ngiot website. Therefore, by participating in this webinar, we assume that you are fine with the recording. Otherwise, if you are not fine with that, you can just leave the webinar. Francesco, I'll give you the floor for a quick introduction, and then we move to the presenters.
Okay, thank you. Pasquale, you just gave a very exhaustive introduction, so I would just like to thank you all for joining us. And today is going to be an important day because the topic of today is very important for our field. It's the base of all that regards cybersecurity and data protection. So I would like really to thank you, Nicolas Ferry, that joined us, and I'll give the floor to him. Thank you very much.
Thank you. Thank you very much. So so as you said, today I'm going to talk about the challenge associated to DevOps for trustworthy IoT system, and some of the answers that we are trying to provide via the ENACT H2020 project. So ENACT is a project which is one of the projects in the IoT SEC cluster of EU project. And let me first introduce the type of system we are talking about here, and we will be talking about in the rest of the presentation. So we are talking about IoT system, but not only IoT systems that gather data from sensor with the objective to upload this get data all the way up to the cloud for processing and further analyzing and so on. But we are talking about sensors that also involve actuators, meaning that we can have some closed loop from sensing to actuation. So where the data is gathered from a sensor with the objective to trigger an action via an actuator. And of course, this closed loop from sensing to actuation, they can be distributed across IoT, edge, and cloud infrastructure, in a sense that there can be several of these closed loop, and you can have basically, for instance, the data gathered from a sensor, pushed and published on a gateway, and then the gateway perform some processing and directly trigger an action to the actuators. And there can be several of this closed loop, and they can be distributed in different places in the smart IoT system. And as in any IoT system, this smart IoT system, as we call them in the ENACT project, they will operate in the unpredictable physical world, which means that typically it is impossible or very, very difficult for developers, designers to anticipate at design time all the situations that a system will face during its operation. And of course, all these properties of smart IoT system, they call for trustworthiness. There is a need to ensure the trustworthiness of this smart IoT system. So very briefly, in the context of ENACT, what we call trustworthiness. So basically, we inspire ourselves from the definition, the NIST definition for trustworthiness for cyber physical systems. And here we say that trustworthiness refers to the preservation of security, privacy, safety, reliability, and resilience. So as I was saying, the smart IoT system, they are running on infrastructure that involve IoT edge cloud devices, and this infrastructure might evolve over the time, as well as the requirements for this smart IoT system, and also, of course, the context. The context of the different devices and services might evolve over the time, and this can be actually quite frequent. And these changes, they are leading to the introduction of new internal and or external threats to the trustworthiness of the system. And we believe that the ability of the system to continuously evolve to their environment, to continuously adapt to their environment or changing requirements and so on, is key to ensure and increase their trustworthiness and overall quality. So, for instance, if you look at the figure here, and if you look at this red line, and if you consider it's basically representing the number of vulnerabilities a system is exposed to over the time, and if you consider the blue dots as a new release of the system, and basically release that are able to handle these newly introduced vulnerabilities, we see that the more often we are able to produce a new release of the system, the better we will be able to handle these newly introduced vulnerabilities, and thus the lower will be the risks or the surface attack, let's say. So, and nowadays, a major software engineering trend for ensuring the continuous evolution of software systems is DevOps. And here what we want to do is, so we believe DevOps can be a way to help ensuring the continuous evolution of this system, and thus ensuring and increasing the trustworthiness and quality of smart IoT systems. So what is, briefly, what is DevOps about? So on the left part of the slide, you can see this figure that probably you have seen in several places, which basically represent the DevOps life cycle, or the DevOps infinite loops. And you can see in this loop the different stages of the development operation process in DevOps. So typically it starts with a planning stage, where you basically will define the subsequent activities in your cycle, and then you have the code stage to develop your software, the build and test. So you test before releasing and deploying. Then you have the continuous deployment. So you want to be able to continuously update your system, continuously deploy or extend your system. And of course, with properties such as trying to minimize downtime and so on. And then once your system is deployed, you will operate it. So you will perform a set of operation activities, and also you will monitor it. And the information coming from this monitoring stage should be sent back or fed your future dev activities. So that's why it's infinite loop, where monitor is directly linked to plan. So often when we discuss about DevOps, key things that come in people's mind is that first, DevOps is about automation. So this is true. One of the value of DevOps is about automation and trying to automate as much as possible the activities in these different stages. But DevOps is also a cultural value. So it's also about this idea to try to have a DevOps team or operation and development engineers participating together in the entire system lifecycle. So in all of these activities specified in these loops. So somehow trying to reduce the gap between development and operation activities. And another core value of DevOps is about feedback, and this idea of measuring everything. So getting information from dev to ops and from ops to dev, and often the main point is about getting feedback from ops to dev, so that drives the subsequent development cycle. So that's kind of DevOps in a very nutshell, and why IoT is challenging DevOps. So there are different challenges, and here we mentioned the one that are of more, let's say, of more focus or of interest for the ENACT project. And the first one is about diversity or heterogeneity. So if we consider that DevOps is mainly coming from cloud computing, we see there is a difference, a major difference between the infrastructure in the cloud-based system and for IoT system. In IoT systems, infrastructure are much more heterogeneous and stable. So heterogeneous both in terms of the hardware and on the constraint on this hardware, but also in terms of the software stack and what can be on these devices. And also, it's much more unstable in the sense that, yeah, these devices, they can have failures, they can have a problem related to energy, lack of loss of connectivity, and so on. So there is kind of a dynamicity also in this infrastructure, which you don't really see in more cloud infrastructure. Another important challenge is about multi-context and scalability. So as I was saying, so typically in this system, in this IoT system, you will have many different devices and many different software components distributed, and they will run in different contexts. And this is even worse in the sense that they can be geographically distributed. So their physical environment can be different from one device to another. And of course, you need to properly understand and handle this context if you want to fully exploit the potential of each of the software components on these devices. And another point related to this is that, of course, more context means higher exposure to trustworthiness threats. And last but not least, another important challenge is the fact that we want to deal with actuators, and actuators can have an impact on the physical environment, and some actuators can have conflicting goals, which you need to understand and you need to handle, and I will come back to that later. So in the context of ENACT, we are trying to handle and provide a proposed solution to these challenges. So the very objective of ENACT is to deliver a set of loosely coupled enablers to support the continuous development and operation of trustworthy smart IoT system. So bunch set of keywords here, and the first one is that the objective is basically to deliver a set of enablers or a set of tools and or services to support the DevOps of trustworthy smart IoT system. And you can see on the figure on the right the set of enablers, so the set of tools that we will deliver in ENACT, and I will detail them later. But what is important here is that we will deliver this enabler as part of the ENACT DevOps framework. So all these enablers, they can be, they are seamlessly integrated and they can work all together as part of this framework. And you probably get most of out of each enabler when using them as part of this framework. But it is also very important for us that you can very cherry pick your own enabler for your own very problem. And just select the one you really are looking or interested in, and they can work independently of each other also. So they can work together in the framework, but they can also work independently of each other. And the idea is that you can just use the ENACT enabler to build your DevOps pipeline or to extend your DevOps pipeline. So basically, these tools are grouped in 3 different toolkits. So we have one specific toolkit for the continuous to support continuous delivery, one toolkit more for operation of your IoT system, and one toolkit which is impacting the 2 others, which is the trustworthiness toolkit that basically provide input to the other valuable input to the other toolkits. So in the next slide, I'm going to detail a bit, present a bit more each of these solution, and I'm going to present an example of a pipeline that you can build using the ENACT enablers. But of course, this is just an example, and could be another pipeline. You could use less tool, or you could use the tool differently, and so on. And then we will see how these enablers they contribute to the different stages of DevOps that we presented in the DevOps infinite loop. So yeah, let's start from the first tool. So we have a first tool which is called Genesis, which is actually our tool for the continuous deployment of smart IoT system. And actually using this tool, you can start specifying the overall architecture of your smart IoT system. So which component will be involved in your smart IoT system, and you can specify where this component will be deployed. And the idea is to support the deployment of this component in a continuous way. So you just deploy every time what has changed in the overall architecture of your system, and try to minimize the impact of the redeployment on the rest of the system. So from this software architecture, you can provide it to another of our tool, which is risk management enabler. And basically, from this architecture, plus from some other model like data flow model, this tool will help you running risk assessment, trying to understand the risk associated to your smart IoT system, with a focus on security and privacy risk. And it will, in the end, provide you with a set of mitigations actions. And these mitigation actions, they can be either development methods or actually feedback on, okay, you should use this different security mechanism or this very different type of devices or cloud service. And basically, this is a valuable input, and you can use it to refine your deployment model and the architecture of your smart IoT system. So once you have this architecture and you know the objective of each of your component, you can either pick some component can be off-the-shelf component or black box component or component provided by third party, or you might have also to develop your own component as part of this software component that needs to be deployed as part of your smart IoT system. And for that, you can use SingML. So SingML is not a tool that has been fully developed in ENACT, but it's a tool that we reuse from another EU project, which was called EDS, and that we have extended, and in particular extended with features for security and for debugging. And SingML is a tool for a domain-specific modeling language, for specifying the behavior of the software component that you want to deploy as part of your smart IoT system. What is interesting with SingML is that it comes with a bunch of code generator, so that from one SingML program, you can generate code in different languages, such as, for instance, code for Arduino devices, C code, Java code, Node.js code, and so on, which means that you can generate code that can be deployed on different type of devices, ranging from tiny devices on the IoT space to more powerful devices on cloud space. And what is interesting also here is that it means that if your code is fully independent of the platform, which can be the case with a SingML program, then you can easily migrate your same SingML program from one type of target device to another. So one of your software component can be specified using SingML. And then one thing that you can do is to provide next your deployment model to a tool that we call Actuation Conflict Management Enabler. So the objective of this tool is to help you managing your actuators, and in particular help you dealing with what we call actuation conflicts. And in particular, there are in the literature two types of actuation conflict. A first type of actuation conflict, which is when different components and different applications, different services are concurrently accessing to a very same actuator, and then you need to manage these concurrent accesses to the actuator. And this is typically, for instance, what is depicted in the figure. If you look at component C3, in that case, where we have, if it's an actuator, then different components are concurrently accessing to this actuator or to these accesses. And the other type of actuation conflict is what is called indirect actuation conflict. So this is typically occurring when you have different actuators within the same physical environment, and these actuators, they have conflicting goals, and then the effect of one actuator is hindering the effect of another actuator. So for instance, if I have a system that triggers the opening of a window, while I have another system that increase the thermostat temperature of the heating system, then okay, the effect of one actuator will reduce the effect of the other actuator. And this is also something that you need to consider and be aware of. So this is a job of the actuation conflict management tools that help you identifying this conflict, direct or indirect, and help you solving this conflict either via off-the-shelf component or by helping you in designing your actuation conflict managers. So in that very specific example, we have a direct access actuation conflict. And basically, what will happen is that thanks to the actuation conflict management enabler, we will be able to put in front of the actuator a component which is depicted here by this red box, which will be an actuation conflict manager, which will manage access to the actuator. So at this stage, we have probably reached a point where we believe, okay, well, our system is almost ready for deployment. And before deployment, we should test it. And for that, we are providing a test and simulation enabler. And the idea of this test and simulation enabler is that you can deploy or deploy your system in a test environment, and then you can simulate gateways and sensors, and to see how your system react to this to data from these gateways and sensors. So you can, using this tool, you can either generate data or you can replay data that the tool has before recorded. And also the tool can inject faulty behavior or simulate security and or privacy attacks. So so you can run this test and simulation, then you end up at a stage where you are happy with the result of the test and simulation. Maybe you have done some new development and tune your deployment model, and then you are moving toward the deployment and then moving toward operation. So there, just before deploying your system, there is a tool which, if you want, can help you diversifying your smart IoT system. So what do we mean by diversifying? So the idea is that you try to generate a variant of your system that are equivalent functionally, so that are providing the very same features, but not exactly implemented using necessarily, for instance, the same protocols or things like that. So increasing the overall robustness of your system to attacks. So since you have different variants, the system will be more able to cope with a specific attack to one type of attack, because the other variant maybe are more robust to that attack. And then once your system is diversified, then you can use again Genesis or the continuous deployment tool to enact your deployment. So deploy your diversified system. And then there is a bunch of tools that are there to help you in the operation and monitoring of your smart IoT system. So on the right, we have the tools for the monitoring, and on the left, more the tool to help you for the operation of your smart IoT system. So on the right, we have, so on the monitoring tools, we have first a tool for monitoring security and privacy. So here we monitor different aspects of your system at different levels. So network, application level, middleware level, and so on. And we try to analyze this to provide high-level alarms for developers. Then we have a tool for root cause analysis. So here, the idea is that in case of failure, we try to help you understanding the origin of the failure by leveraging learning patterns of failure and trying to identify the failures based on the learned pattern. And the last tool is a behavioral drift analysis tool. So here, the idea is to understand to which extent your behavior of your system is as expected during design. So we try to see to which extent your system under operation has drifted in terms of its behavior compared to what was your plan during development. And then you provide a value about this drift that can be used later on dev cycle for improving your system. So this is also a way to handle context. So all this information from the right part of the figure, you see this arrow going up, which means that all this information, they are sent back to dev stages. And on the left part of the figure, we have the tools for the operation side. So there we have a mechanism for security and privacy control. And in particular, there what we did is to extend IoT middleware, and in particular the Sophia IoT middleware with mechanism for security by design. So we have a bunch of off-the-shelf software components that can be automatically deployed by our component tools, our deployment tools, and these components are security and privacy components for aspects like authentication, authorization, and so on. Then we have another tool which is access control enabler. Actually, the full name is context-aware access control enabler. So with objective to manage access between devices and services and services and devices, so both ways, and to manage this access based on contextual information. And finally, we have the online learning enabler. So as I was saying, these systems are operating in the physical world, which cannot be fully, the situation that the system will face cannot be anticipated at operation time, at design time, sorry. And the online learning enabler, what it does is try to help you coping with this unforeseen situation. So we basically try to learn from your experience or the use of the system, from the context of the system, and try to automatically adapt some parameters in the system so that your system behaves more as expected. So one of the input of this online learning tool is a behavioral drift analysis. So this is basically all the tools and enablers we are working on in ENACT, and as you could see, they are basically covering all the different stages of the DevOps infinite loop. So with the continuous risk management, we are covering aspects related to the planning stage. With SingML and the actuation conflict manager, we are covering aspects related to code. For the building, all the things that we produce that the enablers produce are automatically built. We have tools for test and simulation of smart IoT system, tool for continuous deployment of your system, including deployment of security mechanisms, tools for operation, so adaptation improvement, security control, context-aware access control, and tools for monitoring, security and privacy monitoring, monitoring the behavior of the system, and root cause analysis. So I will just now conclude my talk with some kind of exploitation or highlight about some of the result, some of the ENACT result. So one first thing is that since January 2019, a startup called BeAware has been created from ENACT in collaboration with another EU project called PDP4E. And this BeAware is basically focusing on the risk management solution that we are working on in ENACT, and basically their offer is about an easy to use solution to continuously control risk in complex digital system with evidence collection for checking the efficiency of your risk controls. And what is even more interesting, in addition to the fact that this startup was created with ideas that the work made in the project is interesting, is that it already has some early adapters. So both internal and external to ENACT. So actually one of the partners in ENACT, the use case provider providing EL system, is already considering and committed to use the risk management solution from BeAware, and they also have contact with some bodies in the domain of construction. Another interesting aspect is related to context-aware access control enabler, so which is being developed by Evidian. Evidian being one of the European leader in the development of IAM, so IAM solutions, identification and authentication management solutions. And basically, the work they are doing on the context-aware access control enabler will be integrated as one of their products in their portfolio of service for IAM, and will be one of the core solution, core service in this portfolio. And another thing that I want to highlight is that often what is seen as being in the core of DevOps is the ability to perform continuous deployment. And here in the context of ENACT, we have developed quite a large set of solutions to support continuous deployment of IoT system, in particular with support for deploying subsystems. So small systems like one smart building, one system managing one smart building, which has some interesting aspect, such as being technology agnostic, or the fact that you can even deploy software on tiny devices such as Arduinos, or which can be devices with no direct access to internet. We also have, as part of this solution, a mechanism to deploy security mechanism. So for security by design, just selecting a component for a specific security feature, and you can deploy it as part of your smart IoT system. We have automatic support for deploying actuation conflict managers, and this tight interaction with actuation conflict management enabler. And we have also support for managing the deployment of fleet of subsystems. So we can support the deployment of one subsystem, but also of a fleet of subsystems. So making the solution more scalable and providing a feature like ability to deploy in production, preview, safe mode, test environment, and so on. So these are some of the highlight of ENACT. And finally, I just want to conclude with aspect related to the use cases. So in ENACT, all these enablers are going to be evaluated in the context of 3 use cases. First use case, which is from the ES domain. So with deployment of a solution for a development and operation, of a solution for a personal gateway to be deployed in patient houses and help them staying at home, monitoring information about the patient, and with an interesting aspect related to security and privacy. Then we have another use case from the ITS domain, so in particular related to train systems. So basically here the idea is to deploy a system and develop and operate a system to manage train integrity, to ensure that there is basically no split in the train. And last use case is a use case in the domain from the smart building, where we are building application related to user comfort and energy efficiency, and of course use case involving many actuators, and with aspect related also to security and privacy. So thank you very much. That's all I added as part of my presentation. So if you have any questions, comment, I will be very happy to.
Thank you very much, Nicolas. I don't know if your colleague Hui wants to add something. From my side, I really want to thank you, because this was very useful for me and also for ourselves in the context of ngiot. And we will get back to you to have some description of the enablers, because we want to include some of them, or many of them, in the one deliverable on which we are working. So we'll get definitely back to you, because this is all useful stuff.
Yeah, sure. So we'll be happy to provide input. Yeah.
Thank you. Hui, I don't know if you want to add something.
No, I don't. Thank you.
You have the floor.
I don't have anything to add. I think Nicolas presented it well. Yeah.
Let's see if we have some questions from the floor then. If we don't have questions from the floor, I'll give the floor to Francesco, my colleague, as being a cybersecurity expert, he might have some reflections on this.
Yeah, thank you, Pasquale. This was very important for us and for the security cluster community, because we always talk about data protection from a legal perspective, but the fact is the development of the systems is the base to be compliant with GDPR and even with interrelable norms like network and information security. Every time we deal with the implementation of network and information security, that European directive, and the interrelation of this directive with IoT systems, it's very hard to understand how the IoT system can help in the path to the compliance to this directive. The real fact is that extending the perimeter of the possible vulnerable products and things that are connected to the internet, companies are not so sure about the possibility to have trustworthy systems in their premises. To develop with quality assurance, it's something really important to provide safeness and security to those operators, which, just as a reminder, are the essential operators. They provide to the population every single service that is considered crucial in order to sustain our life. I mean, water, electricity, transport, and so on, and health, which is very important right now. So this was very constructive for us, and we would really like to thank you. You'll find the registration of the recording of this webinar online as usual, and we really like to thank you all for joining us, and a great thank to Nicolas Ferry, and we hope we can see each other in the next.
Excuse me, could I ask one question?
Oh, please go.
Nicolas, thank you for your presentation. That was very interesting. Could you say what are the current challenges that you're fighting with when setting up this such a complex system? Are there any specific points that you're working on at the moment?
Yes, so there are many different challenges. So one challenge that we see is related a bit to what Francesco was saying. So it's very difficult for IoT system provider to show and provide the means to evaluate that their system is trustworthy, so that they get trust from the trust customers. And we see that something which is very interesting, and which is also related to the work done in the risk management platform, is there is really a need to help people and companies in performing risk in a continuous manner, so that not just one shot at the very beginning of the design of the system, but regularly. So which means that there is a need for tools that help you do that regularly and in an easy way. And there is a need for tools that helps you in building reports that can help you in being compliant with your standard, like the ISO 27001 standard. And a challenge here is, as part of, for instance, this continuous risk management activity, is to understand the status of your system, understand the status of the development and operation activities, so that you can actually efficiently assess your risk and the efficiency of your mitigation actions. So some of the work is being done in the context of ENACT, where we are collecting evidence in terms of the implementation of your system. But probably some more work needs to be done, and is challenging in terms of collecting even more information from runtime and from the context of the devices. Another very important challenge is related to scalability. smart IoT systems. So typically, if we take the EL system that we are working on, this EL system, so basically you have one subsystem per customer, so one EL system per patient, let's say. And of course, the objective of the company is to have more and more customers, and so more and more of this system deployed in many houses. And the more the system scales, the more they have to manage and maintain and update these subsystems. And one very big challenge, it's not like, even if at the beginning these systems, they look like a single replication of each other on different houses, and exactly the very same, because each of them will run in a very different context. So in different house, with different users, with different requirements, with different devices. Each of the devices is not released at the very same time, will evolve, and so on. So there is a diversity that emerge. And we need some automation in addition to just being able to deploy on the system. We need some automation in terms of understanding the context of each individual subsystem and trying to automate as much as possible operation activities related to this context, so that you don't need operators that manually need to tune each subsystem to the context and end users need. So because if you end up with 1,000 of these devices and subsystems, then you start to use a lot of your or task or human resources just on this operation and tuning. So these are examples of challenges that we see also and that are partly addressed by ENACT, but we see that there will be still room for improvement in the future years. I don't know if I answered your question.
Yeah, absolutely. Thank you. That was very interesting. Thanks.
Okay, so is there any other question that come from the audience? Okay, if not, Pasquale, I leave the floor to you for conclusions.
Well, for my side, it was a learning opportunity. So I don't have conclusion, being an old-fashioned lawyer in a sense. So I had a lot of learning through this, and I thank our colleagues. I see that the security cluster is mobilizing, and we have several initiatives also planned for next few weeks. So you will definitely hear from us, from myself and from Francesco, because we plan to mobilize on our ongoing initiatives, which are ongoing in the cluster, so that everybody can learn and get to know what is going on. So we thank you for your participation to this webinar, and we look forward to our next experience with the ngiot run webinar. So thank you very much for your participation. This webinar can be found and will be found on the ngiot website. Thank you very much for being with us.
Thank you very much. Thank you very much for organizing.
Thank you.
Thank you. Thank you. Have a nice day.
Thank you. Bye-bye.
Nice weekend.
Bye.